So we're going to look at an equation of a line in 3 space. Previously, the equation of a line was defined by y equals mx plus b. The problem with the slope equation is that slope is defined as the change in y over the change in x. But now we have a third parameter, z. So if we want to find a point on a line in 3 space, one way is to think of it as if I have a starting point and I have some direction vector m. I can start at my starting point, move in the direction of m, and hit another point. And any increments of m, or negative m, would be on the line. So let's say this is our line here in blue. If I want to find any point on this line, let's say point P, where P is x, y, z. If we think of it in terms of vectors, we can call this OP. So there's our vector OP. And since OP is any point on this line, and therefore equal to x, y, z, how do I get to point OP? Well, I could travel to a known point, OP naught, and then add the scalar of some direction vector, which we'll call m. If you look at this here, we have a triangle. We're going to go this direction here, and then we're going to take some scalar of m, and we can hit whatever point P is. So this would be OP naught, and this would be some scalar of m. And therefore, we can say that OP, any point on this line, is equal to OP naught, some point that we know, plus we need to take some scalar of the direction to hit that point. So again, one more time, this is any point on this line. This is a known point. And then this is a direction. And finally, if we want the equation of the line, we have the following. We have x, y, z is equal to some known point, that's x naught, y naught, and z naught, plus some scalar of a direction vector with components a, b, and c. And again, t could be any real number. It could be positive, it could be negative. That's how we get all the points on this line. This is called the vector equation of a line. So again, it's the vector equation of a line in R cubed or 3 space. So we need a starting point, that's our P naught or OP naught, and then we need a direction, and that can hit any point on this line. So now let's look at an example. So you're told a line passes through the following 2 points, A and B. So we have some line, and it passes through the following 2 points, A and B. Determine the vector equation of this line. So we need a starting point, and we have 2 of them. We can either use A or B. However, we still need a direction. So let's say we take this as our direction. So there's our direction vector, and notice that's equal to vector AB. So our direction vector m is equal to vector AB, which has components OB minus OA. So subtracting those 2 vectors, I get -2, 0, and -9. Now remember, this isn't the only answer. I could have went from B to A, and that could have been 2, 0, and 9. Or I could have doubled my answer and taken 4, 0, and 18. So any scalar of this vector is a direction. Alright, so now let's write out the equation for this line. So we have x, y, z is equal to, we take one of the 2 points, we can take A or B. So let's say I take A, that's -1, 3, and 5, plus some scalar of the direction vector. So I'm going to use 2, 0, 9 because I don't like the negatives. And this is one possible equation for this line in 3 space. And remember, this is called our vector equation. Next is the parametric equation of the line. And to find the parametric, you just isolate for each component. And all that means is take the x out of the equation from above. So we have x equals -1 plus 2t. We have y is equal to 3 plus 0t. And z is equal to 5 plus 9t. And this is what we call the parametric equations of this line. And finally is the symmetric equation of the line. And to find the symmetric equation of the line, you just isolate for t in each of the parametric equations and put them together. So let's take our equations from above. So we have x equals -1 plus 2 times t. If I isolate for x, I get x plus 1 over 2 is equal to t. Do the same thing with the y. Y equals 3 plus 0t. So that means we get y minus 3 over 0 equals t. We're dividing by 0, so that could lead into some trouble. And finally, we have z equals 5 plus 9t. And that's z minus 5 over 9 is equal to t. And then to create the symmetric equation, we put them all together. So we get x plus 1 over 2 equals y minus 3 over 0 equals z minus 5 over 9. And this is called the symmetric equation of the line. However, in our example here, we have this problem. We're dividing by 0. So we're going to write this in a different format. Whenever there's division by 0 for the equation of a line, you put any of the ones together that you can. So we have x plus 1 over 2 is equal to z minus 5 over 9. And then we're going to use a semicolon and say that y is always equal to 3. So again, when there's a 0 in the direction vector, determine the symmetric equation in a similar way as we've shown here. So again, this is called our symmetric equation of a line. So we have three forms. We have our vector, our parametric, and our symmetric equation of a line in 3-space. So let's go to example 2. Determine where the line in example 1 intersects the xy plane. You're looking for where this line hits the xy plane. And what do we know about the xy plane? On the xy plane, we know that z is always equal to 0. And that's where we're going to start. And for these types of problems, I like to use the parametric equations to determine our solution. So we know that z is equal to 0, so let's start there. So we know that z is equal to 5 plus 9t. We put a 0 there, so we have 5 plus 9t. And if we solve for t, we get -5 over 9. Since we knew that z was 0, now we can find our y value. But for this example, y is always 3. And our x value is equal to -1 plus 2 times that t value. So we get -5 over 9, which equals -1 minus 10 over 9. And that gives us -9 over 9 minus -10 over 9, which is equal to -19 over 9. So now we know that the line intersects the xy plane at the following point. So -19 over 9, 3, and 0. So quickly going over this one more time. If we want to find the equation of a line in 3-space, all we need is a starting point and a direction. And now if I want to find any point on this line, I can sub in a value here. So let t equal some number. So let's say if we let t equal 1, then we would add these two vectors up. So just as a side example, if t is equal to 1, I get that x, y, z is equal to -1, 3, and 5 plus 2, 0, and 9. And this will give me a point on this line. So this would give us 1, 3, and 14 is a point that is on this line. We can write these lines in parametric form. We can write these lines in symmetric form. And then we can also solve problems that involve the intersection of a line with the XY plane, the YZ plane, and so on. So please try the following questions. 14 is a challenging question, so I put a hint here to help get you started.